If you spend the time, you can write detailed code for input-output in assembly language. It's not like building your own automobile from scratch, though, so that you can drive somewhere. The work is really interesting, but it's also very time-consuming. In a later module, we'll get a chance to see how input-output is handled in Microsoft Windows protected mode. It's a lot of fun, and a new world opens up when you see the available tools. For now, however, input-output should be easy while you're learning assembly language basics. This lecture will show how to call procedures from a already established link library named irvine32.lib. The complete library source code will be available in a link on this page in Canvas. Later in this lecture, I will go over how to install it and use it in Visual Studio. The Irvine32 library can only be used by programs running in 32-bit mode. It contains procedures that link to the MS Windows API when they generate input-output. The Irvine64 library is a more limited library for 64-bit applications that is limited to essential display and string operations. A link library is a file containing procedures or subroutines that has been assembled into machine code. A link library begins as one or more source files which are assembled into object files. The object files are inserted into a specially formatted file recognized by the linker utility. Suppose a program displays a string in the console window by calling a procedure named writeString. The program source code must contain a PROTO or proto directive identifying the writeString procedure. So here, writeString proto. Next, a call instruction executes writeString. When the program is assembled, the assembler leaves the target address of the call instruction blank, knowing that it'll be filled in by the linker. The linker looks for writeString in the link library and copies the appropriate machine instructions from the library into the program's executable file. In addition, it inserts writeString's address into the call instruction. If a procedure you're calling is not in the link library, the linker issues an error message and does not generate an executable file. The linker utility combines a program's object file with one or more object files in link libraries. The following command, for example, like hello.obj or object to the irvine32.library and kernel32.library libraries. You have link hello.obj, irvine32.lib, and kernel32.lib. The kernel32.library file, part of the Microsoft Windows Platform Software Development Kit, contains linking information for system functions located in a file named kernel32.dll. The latter is a fundamental part of MS Windows and is called a dynamic link library. It contains executable functions that perform character-based input-output. This figure right here shows how kernel32.lib is a bridge to kernel32.dll. You see you have your program, links to irvine32.library, which links to kernel32.library, which executes kernel32.dll, which your program can also just link to kernel32.library, which executes to kernel32.dll. For now, our programs will link either to irvine32.library or irvine64.object, but later on, we will go over how to link programs directly to kernel32.library. Now let's go over how to, let's say, install or include the Irvine library into your code. So say we have this and we want to run it. You want to call a string called writeString, which would print a string to the your output command line, your command box that pops up, which we'll go over in more detail later. But you go to run it. It says there's some build errors, and it has no idea what writeString is. So the first thing we're going to do is we're going to want to download the Irvine library, which I have in a zip file on the same page as this lecture. You should, once you download it, you'll need to extract all, and then that may take, you know, a little bit of time, probably not too long, 30 seconds or so, maybe a minute. And while this is downloading, once it finishes downloading, you're going to place the Irvine folder, the unzipped one, in your local disk. But you want to make sure, so we open it up, Irvine, we have Irvine, and there's another Irvine. So we just want the inner Irvine. We're going to put that in local disk, and then it's moving. It says that the destination I already have the Irvine in local disk, so I'm just going to exit that out because I don't need to move it, but you will move it. Go back to downloads. I don't need this. Don't need that, but I'll delete that later. Go to local disk, Irvine, and just make sure you have everything in your local disk C. So now that you have the Irvine folder downloaded and in your local disk C, what we're going to go do is go to your project. You can right click that, go to properties, go to linker, and then we will go to additional library directories, and we are going to type C : I want the slash and then Irvine, and we can click OK. Next, let's open that back up. You don't have to click OK yet because you're going to be changing a couple things. So we'll go to linker. We did general. Now we go to input. No, we're at linker, input, and then right here we are going to put Irvine 32.lib, and then we'll do a semicolon. Then we go to Microsoft Macro Assembler. We will go to include paths. We're going to do C : Irvine. Don't forget the slash Irvine, and we can click apply. So let's just double check in general for Microsoft Macro Assembler. We have the C Irvine. Let's go to linker. We have the C Irvine, and in input we have the Irvine 32.lib. So let's click OK. So now if you run your code, okay, it's still not working, and that's because up at the top we actually have to include the Irvine 32 library. So what we can do is we can actually get rid of this, and we're going to type in include. Then we're going to do Irvine 32.inc. Let's now save that, and let's now run it. So when we click local Windows debugger, we can see now it prints out to the screen, how now brown cow. So this is how you download the Irvine 32 library and set it up to where you can now use it in your Visual Studio for MASM.